We're looking at 4.6, and we call this model direct variation. You will write and graph direct variation. Two variables, x and y, show direct variation provided y equals a to the x, and a does not equal 0. The non-zero number is called the constant of variation, and y is said to vary directly with x. The equation y equals 5x is an example of direct variation, and the constant of variation is 5. The equation y equals x plus 5 is not an example of direct variation. Okay, so the point of direct variation is nothing's being added to x. It's just y equals something times x. Nothing's being added or subtracted. That's how we tell if it's direct variation. Okay, we're going to look at A. First of all, we're going to get it in y equals mx plus b form or slope-intercept form. So the first thing I'm going to do is subtract 2x from both sides. And I get negative 3y equals negative 2x. And then what do I do to get y by itself?
Divide.
Divide by negative 3. So y equals 2/3 x. Now, is this direct variation? Yes, because nothing's being added or subtracted from it. So what is the constant of variation? What's the constant of variation? What's the number in front of x, the slope? 2/3. 2/3 is the slope, and we call it the constant of variation. Okay, we're going to look at the next one. We've got negative x plus y equals 4. So the first thing I'm going to do is I'm going to add x to both sides. And I get y equals x plus 4. Is this direct variation? Yes or no? No, because something's being added to it. So no, it's not. Okay, now we're going to go to example 2. And we're going to graph. Okay. All right. Someday my computer will work better here. All right, so we're looking at example 2, and we're going to graph direct variation. We've got two things we're going to graph. First, we're going to graph y equals 2/3 x. So for direct variation, what is nice is the y-intercept is always the same. But what is the slope for this one? 2/3. Okay, and the y-intercept is always the same for direct variation. It's always, is there anything being added or subtracted? So it's always 0. Okay. So now we've got our graph, and you've got much better graph paper than me. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you have graph paper. You don't need to worry about that. It's right there on your graph, Mark. It's right there in your graph. So we're going to start with 0, which is our y-intercept. And then we're going to follow our slope. From 0, I'm going to go up 1, 2, over 1, 2, 3. Or I can do the opposite, because negative 2 over negative 3, that solves for 2/3. They're the same thing. So I'm going to start here. I'm going to go down 1, 2 over negative 3. And I get a nice straight line, and its direct variation goes through 0. All right, let's look at the next one. We've got y equals negative 3x. First, what's my slope? Negative 3, or we could call it negative 3 over 1. And what is my y-intercept always when I'm doing direct variation? 0. Good. Okay, so now I'm going to make another graph. You've got graph paper, so you don't need to worry about this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. we always start at 0 because that's our y-intercept. And then I'm going to go down 3, 1, 2, 3 over 1. Or we know that 3 over negative 1 is the same thing. Up 1, 2, 3 over negative 1. Any questions about graphing? Any questions about graphing? We understand that we started our y-intercept, and then we, from that point, follow our slope, yes? And you guys have to practice this. You've got to do your homework so that you become proficient in this. Okay, we're looking at example 3. The graph of a direct variation equation is shown. We're going to write the direct variation, and then we're going to find the value of y when x equals 30. So you guys have this pretty graph on here. So the first thing we're going to do is we're going to put it in y equals mx plus b form. Okay, first of all, where does it cross the y-axis when you look at that graph? At what point does it cross? Somebody raise their hand. What point does it cross? 0. Let's try raising our hand, though. Okay, it crosses at 0, so that's my y-intercept. What is my slope? It goes down how many over how many? Looks like it goes down 2 over 1. So that's negative 2 over 1. So it's y equals negative 2x. Okay, if x is 30, how am I going to find y? What am I going to do for part B? This is part A. For part B, what am I going to do? X equals 30. How am I going to find y? I heard it, we're going to plug in 30. Y equals negative 2 times 30. Negative 2 times 30 gives me y equals negative 60. Okay, let's go down to example 4. All right, let me draw this table quickly.
So instead of going from the 0, you started at the top and went down to...
Or I went up to over negative 1.
Up to, okay.
So I've got this chart with number of songs, and this should say cost, C in dollars. And then if I have 3, 5, 7 songs, it's $297, $495, and $693. First, I want to write an equation explaining why C varies directly with S. Then I want to explain why, and then I want to write a direct variation equation. So, 297 to 495. So I want to find out how much is this. I go from I'm going up 1.98. Okay, is it the same? 6.9593, excuse me, minus 4.95. I went up 1.98. Okay. So Hey, it goes up 1.98 each time, but I go from 3 songs to 5 songs, and from 5 to 7. How would I figure out how much it costs per song? I would divide, good. I would take like $2.97 divided by 3, and I get 99 cents. Well, let's see if that works. 99 times 3 gives me $2.97. 0.99 times 5, does that give me what I'm supposed to have? Yep, $4.95. 0.99 times 7, oh, it gives me $6.93, perfect. So I am taking the cost equals 99 cents times the number of songs. So I found out that it went up $1.98 each time. So I was like, okay, it's the same each time. So let's figure out how much it costs per song. We did that by taking $2.97 and dividing it by 3. And we found out that that was 99 cents. So then we took it in our y equals mx plus b. We know if we got 0 songs, how much would it cost? 0. So I know each song costs 99 cents. Any questions about this? All right, ladies and gentlemen, get out your writing notebooks.